See, students, I'm going to pose an important question. Whenever we stand in front of the dressing table, we see our image, but why don't you see your image when you stand in front of the wall? What is the reason? Okay, you have to understand this thing. So, this is a mirror. Actually, mirror is made of glass. Is glass a transparent material or opaque material? It is transparent, but it has two surfaces, before and after, outer surface, inner surface, inside, two surfaces. So one of the surface is silvered, that means silver is applied. Nowadays aluminum we are using because silver is costly, so that aluminum will be coated on the surface and then painted. Then automatically what happened, the surface, actually mirror has some thickness, right? The light which incident on this mirror passes through the first surface, but reflection takes place on the second surface, because second surface become opaque, not the first surface. So the ray which is incident on it, then what happen? Reflects back, because we make this glass into mirror. Sorry, mirror. Glass is actually transparent one. Glass is transparent one, but we made this glass into mirror. Mirror is opaque one. Okay. What about wall? Wall is a opaque body. Now mirror is also opaque body. You understood these things. Then when both are opaque bodies, then why do we see the images on the mirror? Why don't we see images on the surface of the wall? What is the reason? So for understanding that, you have to understand one more important concept. This is a single ray. Ray has starting point but no end point. Single ray. I'll take such kind of rays, a group of rays, a bunch of rays. Beam. This is called beam. Beam, nothing but group of light rays or a bunch of light rays. But all the light rays in this group, they are passing parallel to each other. The angle between each and every light ray is 0 degrees, 0 degrees, 0 degrees, 0 degrees, right? That is why this kind of beam is called a parallel beam. What is this called? Parallel beam. Now, another beam. This is the source of light. From here, a group of light rays are passing, but are they passing parallel like previous? No. From one point, they are going to different directions. They are deviating. They are deviating. That is why this group of light rays called a divergent beam, and from different points rays are coming and meet at one point. They are concentrated at one point. This is called a convergent beam. Now, where do we see the single ray? In exhibitions. Okay, in exhibitions we find a laser light, 25 rupees, 60 rupees laser light. When we switch on the laser, only monochromatic. Mono means a single, chromatic means color. Single chromatic light travel long distance and one red color or green color spot will be formed on the wall. So that is single ray. Parallel beam. Sunlight is best example of the parallel beam. Okay. When source of the light is far away, we get parallel beam. So I am going to do an experiment to understand the parallel beam. Okay. So here I am going to place two markers this way. How are the markers? They are parallel. Right. I am going to switch on the mobile light, torch light. Then this light is incident on the marker. Okay, so when I kept the mobile phone very close, you see the shadow of these two markers, one is goes this way and other goes this way. See, yes, shiva lights off chestava anda, so light off cheyi. See, this is the, I kept two markers parallel to each other. When source of the light is very close, you see, when I kept the source of the light is close, you observe the shadow of the markers. The shadow of this marker goes this way, this marker goes this way. Why? What is the reason? Why the pens are parallel, markers are parallel, but the shadow is divergent. And same thing you see, I'm going to keep this mobile away. When I'm bringing this mobile away, okay, you see the shadow is parallel. Okay, you see the shadow is parallel. When I bring this mobile very close, shadow is diverging, but when I am going far away, you see parallel, the shadow becomes parallel. What is the reason? So the reason I will explain. When source of light is very close, when source of the light, let's say candle, when source of the light is very close, from here many rays are going to incident. These are all divergent light. Okay, candle is the best example for divergent light. When source of the light is very close to the markers, divergent light incident on them, that is why the shadow also becomes divergent. But since whenever we place this candle very far away, when we place the candle far away, the rays which are diverge, as they are traveling long distance, they become parallel. Okay, now parallel beam is incident on the pins, then shadow also will be parallel. Okay, shadow of the pins also parallel. Where is the sun ahead? Sun is 15 crore kilometers from here. 15 crore kilometers is a short distance or long distance? Very far. Sun releases divergent beam, but since the divergent light rays travel these much distance, these many kilometers, crores of kilometers, then what happened? They become parallel. That is why whenever in the daytime you do this experiment, children, you keep two markers in the sunlight. This way you keep parallel and observe the shadow. What kind of shadow you will find? Parallel or divergent? You will find parallel, because source of the light is far away. So what is the best example for the parallel beam? Sunlight itself. Okay, so here it is, laser is the best example for single ray. For parallel beam, sunlight is the best example. Divergent beam example, just now we have discussed candle, tube light, torch, okay, vehicle headlights. All these are the best examples of divergent beam. Convergent beam, see, I hope you have seen magnifying lens, and you children played with magnifying lens also, I hope. What happened when sunlight is incident on that magnifying lens? What happened? After refraction, all the light rays concentrate or meet at one point. So there the temperature is very high. Whenever we keep one matchstick, it catches fire, it starts burn. Yes or no? We played in our childhood this way. This is magnifying lens. Here what is happening? The rays which are incident on this lens, all the rays going to meet at one point. So this is the best example for converging beam. Okay, convergent beam. So example is concave mirror. I will show you concave mirror and convex lens. So this one is made of convex lens. Okay, convex lens. or biconvex lens. This magnifying lens is made of convex lens. So these are the best example. They produce convergent beam. Okay, so laser produce single ray, monochromatic ray. Sunlight is best example for parallel beam. So all these sources of light produces divergent beam, and these two mainly convert that light rays into, they make to meet at one point. These two objects make the light to focus, concentrate at one point. Okay, so these are the best things. Please note down all these things. Just pass it. So just now I asked one question. Why don't we see our image on the wall? Why do we see our image in the mirror even though both are opaque? Now, for understanding, I consider the parallel beam. Let's take, imagine the surface is very smooth, an even surface. It is an even surface, very smooth. Smooth and even. Okay, and it is opaque one. What happens now? A parallel beam is going to incident on this. Here parallel beam is incident on the smooth surface. Okay, then what happened? Already we have discussed light obey two important laws during the reflection. Incident ray, normal, reflector ray lie in the same plane. Angle of incidence is equal to angle of reflection. See here, these are the reflector rays. You see, after reflection, if you observe the light rays, they are also parallel, because here every time angle of incidence is equal to angle of reflection. This kind of reflection is called regular reflection. But same thing, same parallel beam, whenever it incident on uneven surface like this, but it is opaque, uneven surface. Okay, when parallel beam incidents on it, can we expect the parallel beam after reflection? Might not. It may go this way, this ray go this way, this ray go this way. Okay, so this kind of reflection is called irregular reflection. Whenever we consider smooth surface, a mirror surface is smooth. That is why when we stand in front of the mirror, the rays which are going to incident from our body on the mirror after reflection again parallel, they reaches, we can see our image in the mirror. But same thing when you stand in front of the wall, that wall has rough surface, rough surface and uneven surface. Then what happened? The rays which are incident from our body on the wall, they diverge, they goes to different directions. They doesn't reach us. That is why we cannot see the image of ourselves on the surface of the wall. So this is the main concept. So regular reflection on smooth surfaces is responsible for the formation of image. Best example. For example, this is the floor, this is the smooth floor. When you take the rubber ball and when you hit the rubber ball like this, the rubber ball after hitting the floor again coming to your hand. So this way you will play. By standing here itself without moving anywhere, you can play with the rubber ball. But you place some marbles or you place some gravel, stones and something on the floor and you try to hit the rubber ball. What happened with rubber ball after hitting? Can it come back to your hand? It may be go to any direction because surface is not smooth. Another example I will tell you. For example, it was rained yesterday. Okay, there are some pits on the road. That pits are filled with water. Yesterday it was rained, heavily rained. That is why the pits are filled with water. Next day morning, that means today, a boy is walking beside the pit. Whenever he see himself in that pit, water, complete image of himself he see. When he see his image, Okay, suddenly his one of the friends dropped one stone in that pit, small stone. Then what happened? Water, surface of the water get disturbed. Before the his friend dropped stone, how is the surface of the water? Still surface. So it act like a smooth surface. So his image he find. But once the stone is dropped, the surface become uneven. Can we find the image properly in that? No. So same thing. So reflection on smooth surfaces is responsible for the formation of image. Okay? Right. I hope you understand the answer for my question. Okay? We are going to understand the relation between angle of incidence and angle of deviation. A relation between angle of incidence and angle of deviation. See, using the symbols, angle of incidence is denoted by I and angle of deviation is denoted by D. Okay? So this is the relation between I and D. Now we are going to talk about. So we are going to talk about the relation between I and D. So this is the smooth, plane, opaque surface. A ray going to incident on this. After reflection, it bounces back this way. This is incident ray, this is reflector ray, and this is normal we have discussed. This one is angle of incidence and this is angle of reflection. This is the actual path of the light. The light has to travel this way, but instead of traveling in its actual path, it deviated through some angle. This is called angle of deviation. Now we are going to find the relation between this I and D. So this is the straight line. This is straight line. So I'll denote O, A, B, A dash. So O, A, this A, O, A dash is a straight line, right? So A, O, A dash is equal to 180 degrees because it is a straight line. In this 180 degrees, how many angles we have? I, R, D. All these three angles together make 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation, all these three together make 180 degrees. But we know that from the laws of reflection, just we have discussed previously, angle of incidence is equal to angle of reflection. So in the place of I, we are going to write R. In the place of R, I also can be substituted because both are equal. So in the place of R, I am going to write I because these both are equal. I plus D is equal to 180 degrees. I plus I, 2I plus D is equal to 180 degrees. We want D, then bring this 2I from LHS to RHS. After transposing, we get 180 degrees minus 2I. So this formula gives the relation between angle of incidence and angle of deviation. R D is equal to 180 degrees minus 2R also can be written. Why? Because I is equal to R. Okay, in the place of I, R also can be written. So this formula gives the relation between the angle of deviation and the angle of reflection, this R and D. Okay, and one more. Here from this figure, we know that this is glancing angle of incidence IG and this is angle of incidence. This is perpendicular line which we drawn from the at the point of incidence to the opaque surface. So this is 90 degrees. This is 90 degrees. So in this 90 degrees, two angles we have. One is angle of incidence, another one is glancing angle of incidence. So from the figure, we can write IG plus I together make 90 degrees. If you want IG, then you have to subtract angle of incidence from 90. 90 minus I. plus I transpose minus I. If you want I transpose this Ig, you have to subtract Ig from the I. Okay, this is the relation between angle of incidence and glancing angle. If you want I, subtract this Ig from 90. If you want Ig, subtract this I from 90.